Jej, ja się tam wydałoby. Wait, are she like, oh, really?
How's our Thursday? How's your day off?
This
Spent 2 days
weekend,
at home.
this weekend I get to go to my dad's house and open.
Oh, the new one, that's cool.
That's fun.
I
The
did,
weekends never not good for me. I had a better feeling. You know what I get? Is A, they were together for 25 years.
I was in the hospital. There's something wrong with my heart. First an A.
this is all not good news. I'm so very
What do you got? More bad news?
No, I want more good news.
Well, 2020 will
I
get
got
worse.
my 20.
In 45 years, actually.
Fun.
But you know how we're making a joke, 2020 can't get worse, or an asteroid.
It already is getting worse.
2020 is crazy.
Anyway,
The scientists have said that.
first I did start looking at your tests. Put some grades in, I wasn't able to grade everybody.
I forgot to do it.
We started it.
Yeah, but then when I went back on it, because I had to read the thingy, it didn't save.
I know, so both of them would save on mine, so I could see that you came in twice. So I would grade the first part up until, I don't know, maybe question 3 or 4 where we made it.
I mean.
And then if you go in again,
7, I'm pretty sure.
so then if you go in again and just jump right to question 7, then I'll just look at 2 assignments. You don't have to redo it, you know what I mean?
Okay.
Did you already redo it?
No, because once I saw it, I was like, okay, I'm just gonna put it.
Yeah, no, and that's for anybody who may have started it and didn't finish it, and anybody at home that may have started the test and didn't finish it. It doesn't save on your end, but it does on mine. So if you got kicked out yesterday, just open back up, go to the question you left off on. I'll figure out where to grade and what's down.
And it was hard to focus yesterday because my little baby cousin came over.
Right, which is fine, so there will be some time, your 4th period, 9th period, things like that. Now you can get that all finished. But your grades are closing on Monday. So all of these big type assignments, the quizzes, the tests, the projects that I've been kind of pushing you to do and complete, I'm gonna make sure you're getting those in before the end of the month, it's just that you're grading this stuff. Okay, so we are starting we're starting unit 3, which is all about circles. So we're doing a lot of measuring stuff today. Those of you that are at home have a link. You are gonna kind of go through this on your own. There's directions, but the size of the images that you're gonna work with are different than ours. So it's just not gonna work out.
Why are you on page 2?
I think mine's different because I don't have the A, B, C, D
You
squares.
guys here don't do anything yet with your iPad. Don't do anything yet with your iPad. Those of you in the room. Okay, I'm giving us nice paper copies to measure because it's a little bit easier.
I'm not using that.
Okay, those of you that are at home, if you follow that link in the Desmos, the first slide is gonna tell you what you're gonna need, and I kind of sent you some messages about rollers. I sent you home with rollers on Monday. You're gonna notice that you have 6 squares, and you're gonna follow through with those directions. We're really gonna do the same thing also. We just have a little bit more because there's more of us in here. What I need you to do, and you guys, I'm gonna give you a roller in a second, I need you to measure the diagonal. What's the diagonal of the square? What do you think? We're looking at these. Sitting. Huh? So when you're measuring the diagonal, that's the first thing we're gonna put in our table, it's corner to corner. So the first thing we're all measuring is corner to corner. You need to know one side length. We're gonna measure one side length with the perimeter of the square. Sydney? You're gonna measure the entire outside, and we also wanna know the area, okay? So again, those of you at home, I sent you home with rulers. If you're virtual, I kind of uploaded one for you. You are just working through this set of Desmo slides on your own. There are 6 slides, work through it, stay in the Google Meet in case you have questions. But the images you're seeing on your iPad are gonna be different sizes than ours, and it isn't gonna work out to keep us all on the same page. But if you have your ruler out, you're gonna measure those 6 squares on your screen, diagonal, side length, perimeter, okay? And just keep moving at your own pace through these Google slides, stay in the Google Meet in case you have questions. You guys, I'm passing out your rulers, and we're gonna go through it together. I didn't pass them out yet, Parker.
Thank you. The whole.
Okay, so everybody in the room right now, all we need to really look at is this piece of paper. So everyone's gonna be assigned 1 square, and we're gonna go through and measure those same things that I was just explaining to you at home. We need to measure a diagonal, we're gonna measure a side length, and then we're gonna calculate a perimeter and an area, okay? So everybody,
I have a calculator.
yes, allow me to explain, please.
I don't know.
Okay? Everybody's gonna be assigned 1 square, because I believe there's 9 of us in here, okay? A, okay? B,
Can I have 8?
B, C. Y, you're gonna measure D. E. Parker, are you paying attention?
Yes.
You're in charge of F. G. H.
I get the
Okay. So what that means, the first thing we're gonna measure, and you're gonna write this next to your square, is measure the diagonal length. Again, your diagonal length is corner to corner. So 1 corner to 1 corner. What are you noticing might be difficult about using these rulers?
It's easy for me. Yeah, not you.
Is your ruler nice and perfect? No. Do you have to maybe do some estimation? Okay. So you might fall right in between 2 numbers. Do your best to estimate what your diagonal length is, and then on your paper, just write D equals, and then whatever your length is. And again, you guys at home are free to just move through this on your own, answer the questions, get to the end, check in that you're done, and then you're gonna be free to kind of go.
I have a calculator.
You don't need a calculator right now.
When I did it.
We're all staying on the same page here.
Are we dividing?
We're not doing anything.
Just what? Just make D equals. Did you measure it?
Technically, we all do somewhere.
D equals 4.
We're measuring, that's really.
Everybody understand how to measure the diagonal? We're all good. Ready to move on?
Wait.
What?
Am I supposed to know?
Just write it down. Right next to your square, say D equals, and then whatever you got.
B equals 7.
Okay, so then they're next to that inside of it, you big square, so D equals 7.5.
Yeah, 7.5.
The next thing you're gonna measure is 1 side length. So then next to your square, just say S equals. So just any side length. There's 4 of them. They're all gonna be the same. Just measure 1 of them. Again, those of you at home, if you have any questions on anything, your numbers are gonna be different than the ones I'm sharing in the Google Meet, but I will still help you. I just know that your devices and your screens are different sizes. So measure 1 side length, write it down. Did you measure a side? Measure this side. We did, so now we're on the second one, so just measure that side. So that should be, okay. So your diagonal.
Miss Leonard,
Yes, what's up?
I don't have a roll.
Okay, Noah, give me 1 second.
So
D equals 8. And measure your side length. S equals whatever. No, if you don't have a ruler, then just stay in the Google Meet and just watch as eventually we're gonna type stuff in, so just follow along with the screen. Okay, so we're good with the side length.
Yes.
Now we need the perimeter. Anybody know how to calculate a perimeter?
Would you do like multiply all the sides?
But we'll not multiply all the sides.
Right?
Close. Like, you're saying the right thing, press,
Add.
you're adding up all of your sides, or if there's 4 sides, you can take your side length and multiply it by 4. So whatever your side length is, does anybody need a calculator?
Yes.
Make sure you're using your side length and not your diagonal. So whatever you just measure, multiply it by 4, and then tell me, or right underneath it, say P equals whatever you get.
Okay. Now we have to measure.
Did you find your perimeter, Parker?
Perimeter.
Huh? Did you do the perimeter?
7.
Did you measure your side? So what was your side? This one looks good, but your dimensions back to 10. Yep, that's it. So the last thing we need to calculate and have written on our paper is the area. What's the area? Or how do I find the area of a square? Length times width. So a square, all of your side lengths are the same. So if I want to find the area of a square that's side length 5, what do I do? Multiply your side length by side length. So whatever you have for your side length, multiply it by itself. Your side length is 2, do 2 times 2. If it was 4, do 4 times 4. Tell me what the area of your square is. You should have 4 things written on your paper so we can move on. Diagonal, side length, the perimeter, the area. Side length, 7.5. Perimeter, I want you to take this number and multiply by 4. Area, I want you to take it and multiply by 7. Okay. Sorry, so now all I have to do is 3 times 4. And then say A equals whatever you get there.
Already made it.
Oh, you already know this.
Let's say 8 equals whatever it is.
So are we good with all 4 pieces? Moving very slowly here because we're all gonna share the data instead of all of us measuring all of the squares. So we need to make sure we have everything correct. So are we all good with all 4 pieces? Diagonal, side length, perimeter, area. Yes, no, maybe so?
I got 30 for the perimeter.
Just 4 times 4.
I did.
It's just 4 times 4. I'm 4 times 4.
I know. What, Parker?
I got 30 for the perimeter. I guess that times 30 by 7.5 now.
What?
Doesn't matter.
7.5 times 7. Okay, now you guys can go into your iPads and open up the tab. Because it's gonna bring you to this so that we can type it in and graph it. So we need to make sure we have all 4 of those numbers as accurate as possible. Why are our numbers probably not 100% accurate? Right.
Is the ruler I got here?
Right, and we're estimating, there's not really a bunch of tick marks. We might be estimating it at 7.3, and it might be 7.2. We're going to Google Classroom, click on the live lesson, it's gonna take you here. We're gonna fill out the table with all the numbers we just got. Then we're gonna graph it, and we're gonna work to figure out if it's proportional or not. Y'all in? Okay, so then square A, that was the RJ, what was the length of your diagonal?
4.
Okay, so everyone type in a 4, and then what's your perimeter?
4.
No, your perimeter, sorry, I'm skipping this side then. What's your perimeter?
16.
16. Square B, Levi, what did you get as your diagonal? 8.
I'm supposed to keep it out because I put it in my backpack.
You're done, yeah.
Okay, 8. And then Levi, what was your perimeter? 32. If I take, oh wait, no, you're probably right. Sorry. What did you get, 24? Yeah. C, Heather, was that you?
Yeah.
What was your diagonal?
It was 3.5.
3.5. And what was your perimeter?
Square B, it was a 6 and.
It's an 8, Parker. And a 24.
Wait, how did it go down?
Oh, it's a smaller square. We're just typing these numbers in the table along with me. That's all.
Oh, the centimeters. The perimeter were.
Your perimeter.
All the way back here.
Okay, that's why we all need to be listening. I'm telling you the numbers.
2.5.
Follow along. As I go, you go. So we have a 4, 16, 8, 24, 3.5. Heather, what is your perimeter?
10.
Okay, about 10. Are we good? And just follow along and listen as I go, and then you'll have no issues.
So 3.5 and then like.
10. Yep. You good, Wyatt? Okay. You good, Amoen? Okay. You good? Okay. So then on your paper, your turn's up. That's why I'm waiting for you. What's the length of your diagonal? You said D equals what on your paper? 4. So we're gonna do 4. And then what's your perimeter?
12.
Yep. So perimeter of 12. Okay, Elena,
Not 4, yeah.
4 and 12. Square E. What's your diagonal?
5.
About 5. And then what's your perimeter? 20.
5. And
20.
Can we leave and they finish?
Yes. Sorry, I just actually saw your comment in there.
alright. I guess I'm next.
Parker, yep. What was your diagonal?
It was 7.5.
Perfect. And what was your perimeter?
Mm-hmm. 30.
Perfect. And then G, where'd I go here? Sydney? What'd you get as your diagonal?
2.
2. And then perimeter of square G is what?
6.
6. Square H, Rich, is that you? What'd you get
9.
for your diagonal?
Yeah.
Okay. I'm writing my numbers, not your numbers. And what's your perimeter? Perimeter, that might be your area. What'd you get? It's close to what I got. Okay, so for square H, we're gonna do our diagonal as, we're gonna stick with a 9, the perimeter is about 34.
Very cool.
Square I, Chris, what'd you get? Diagonal is what?
5.5.
5.5, perfect, exactly what I got. And what's your perimeter?
16.
Okay, about 16. So now we measured the diagonals, we measured the perimeters. Are we all okay with typing it into the table? What I want us to do now is start working on this graph. Diagonal length is on the X, perimeter is on the Y. So when I come to plot square A, I'm gonna come over to 4, because that's my diagonal length. And then what's the perimeter for square A? 16. So we're gonna go all the way up, we're counting by 2s, so 10, 12, 14, 16. So that's square A. Square B, come all the way over to 8, and then up to 20, 22, 24. So plot those points. You're gonna have to estimate, because they're decimals, but square C, 3.5 to 10. Plot all of these, so you're gonna get sort of a little dot graph. We all understand?
So we're graphing, so this is, we're gonna go over and then up. So you're gonna come over to 3, and then up to 16, and bottom. Okay. You can kind of just guess where 16 will be. In between 10 and 20, right? Okay. We're gonna do that for all of them. So 4, 16, over to 4, up to 16. Okay. What are you doing? Why? I don't know. You're doing a graph? Okay, get rid of your people.
You're plotting your points. What are you noticing is difficult about plotting your points? Sydney? So it's not 100% nice, super straight line, it's a little bit curvy. Plot your points. Okay, what's wrong? That's okay.
Right where the line is. It's hard, that's the whole purpose. Yeah. Because you have volume. No, you don't. You can do the same part.
So finish up plotting.
Like this?
So I'm at 3.5 to 10. 4. 12. 5. 20. 10.5. So 30. Heather, why are you not plotting? Why are you just sitting there?
Graph is only like.
Okay, so even if you weren't able to get them all plotted, you can kind of stop where you are just to look back at where ours is. It's okay, it's not done. For the most part, is that what your graphs kind of start looking like? So what do we notice about the graph? Cindy? It seems like it might not be proportional. Why might it not be proportional? So it seems like the dots are all over the place. If I go ahead and try to connect them, we know that down here, that's where I'm starting. It has to be this straight line. So it does kind of look like they're a little bit all over the place, but why might they be a little bit all over the place?
Because of the different lengths.
Because of the different lengths. And again, it's going to take us into our conversation. Do we know if we 100% measured all of this stuff correctly? No. So we estimated it. So there is a little bit of error in our problems here. What I want everyone to do in your table in this last column is to find your constant of proportionality. So that means you're gonna take the perimeter divided by the diagonal for all of your squares. 16 divided by 4, 24 divided by 8. Find that constant of proportionality.
Is there a divide button?
I don't actually know this is. So on that last column in your table, perimeter divided by diagonal. All the way down.
In this column, 16 divided by 2. 4 divided by 2. So divide out your numbers on this side, do 16 divided by 4. Like your numbers right there.
And then keep going down. Divide them all the way down. Those of you that are at home, depending on what slide you're in, if you start to finish up, you can sign out.
The first one was right.
Okay, so what you should be noticing as you're dividing is that you're getting numbers that are a little bit different. 3, 4, 2.8, right? Things around that are your numbers that you're getting close together. Sort of, okay? So in unit 3, with all this measurement, we're still typing, it's okay, you can put your calculators down.
It's kind of rough.
Just starting to see the patterns. What?
I'm doing this 3.5 times 2.8, 9.8.
Because you rounded, right? You didn't get exactly 2.8 there. So you're not gonna get exactly 10 back. Okay? But again, if you're done, or if you're not done with the typing in the calculator, put your calculators down. It's okay. Okay? But what you should be noticing is that the numbers you're getting are kind of close together. Just like the points on the line are kind of spread apart, but they have a general formation of a straight line. So at first we looked at this and said it's not proportional. Why did we say right away that it wasn't proportional? Sydney? Because it didn't make a straight line. But we have to take into account all of those errors we may have made whenever we measured. We have this piece of paper roller that who knew who drew it? We don't know how accurate it is. It was hard to put it on the shapes and understand exactly how long the length was, how to calculate that perimeter. So we made a little bit of error in our measurement. So that's showing up in our graph by our points being kind of far apart. It's also showing up in the dividing that you're doing because your numbers are a little bit far away from each other. When we start getting into this talk and discussion about measuring and figuring out proportional relationships, it is okay for things to not be 100% perfect.
Some are all.
Right. I had a conversation with Wyatt because he tried to put it here and it went a little bit to the side. Because there's human error, you might move your finger whenever you don't mean to, there's measurement error. It is impossible in the world to have everything super nice, neat, and even. But if you're just looking at this graph, is the general shape of this graph a straight line? If you look at the pattern of the points, in general, do they seem like they're increasing?
Yes.
Yes. Again, they're a little bit off because of all of those errors that we made. We didn't all measure the same shapes, so RJ might not have had no idea what he was doing with the ruler, so his might be way, way, way off.
Mine do.
Doesn't mean that it's not proportional, but we're accounting for that error in the measurements that we're doing. What I want you to do is skip the next slide. Come to slide 5. Slide 3. Should be looking at this graph.
But which one?
Slide 3.
Okay, this one's not proportional.
Okay, so it says the graph shows the height of a plant after a certain amount of time measured in days. Do we think it might be proportional?
No,
Why not?
because it's not a straight line.
It's not a straight line, but we're talking about measuring the height of a plant. Can you perfectly 100% every single day wake up, measure something, perfect, everything's A-okay, looks great, the world is a nice straight line?
No.
No, right? Could be one day where it wasn't as sunny, so it's a little bit lower. Could be something that your ruler is broken. But we're looking for, in general, is the shape of my line in an increasing pattern? Is this, for the most part, increasing?
Yes.
Right. If I try to draw a straight line through it, I might hit majority of my points. They're just a little bit off, accounting for that measurement error and that human error. So for this one, we are going to say yes, and then explain your thinking. The pattern is a straight line. Human error accounts for mistakes, or mistakes happen. It is okay to not have everything perfect. But in general, it's a nice straight line. Pattern is a straight line. Mistakes happen and cause errors. So when you're responsible for doing something, measuring something, and calculating something, it's impossible to do it perfectly. We were doing that, I forget what we were looking at last week. And Chris was kind of saying the same thing, it's not proportional because it's not perfect, the world's not perfect, I can't remember what it was. But it's that same idea. For the most part, it's proportional, a little bit off to account for those mistakes we may make whenever we're measuring. When you're done with that, click the next slide, you can answer the next question. And the main idea is that you're looking in general, does it seem pretty straight and in a nice pattern? Or is it definitely way, way, way all over the place? Little tiny differences are okay.
This is definitely not proportional.
You said that last time.
No, it's definitely
Okay.
Because it's not a straight line.
So you should be looking at this one. What do we say? Sydney?
I said no because it's not really increasing.
Right. I also agree with Sydney. I agree with Parker, who said that's definitely not proportional.
I also said no because no, the line is not going straight. The person has made a mistake because
So I agree, definitely not. Even on the other one where, yeah, we had a little bit of mistakes, the pattern of my points was still increasing. But like Sydney said, we come up here and then pick this place where we're not even moving. All of these points are really far away from that pattern that should be up here. So it's not proportional. It's not in a straight line. Doesn't even look like it's anywhere near a straight line. So there's a lot, way too much error happening to be even considered proportional. That makes sense? Again, the main idea is that in Unit 2, we were looking at these nice perfect relationships, everything 100% accurate, but if we get into measuring and all of these things where we as humans can make mistakes, it might not be as perfect as we think it is. So we can log out of there. Your homework is a set of practice problems. It is linked in Google Classroom. We can work on that when we come back ninth period, because there's only a couple of minutes left in here. It's a handful of Desmos problems instead of being in the book. Those of you at home also have the same set of problems. You can sign out when you're done with this. Sign back in ninth period for your attendance. We're going to be working on the homework.
Wow, I went fast. I wonder how long all this is.
25 questions.
It's actually 6.
This class has got like 20 minutes.
The papers you can just put in their recycling bin when you walk out.
Keep our paper. I want to color all these squares.
If you wanna keep it, you can keep it.
I want where I use the ruler. Do I keep the ruler off the scale?
Okay, same you for saying that, the rollers, listen, your rollers leave on your desks.
Oh,
Cause yeah, cause I know, papers, toss into recycling, rollers leave on the desks. If you wanna keep the paper, you can keep the paper. I feel like normally it's like opposite, I'm like, keep the paper, and you're like, can we throw it away if we want?
Yeah, thanks to
And
you,
I'm
I
like,
throw
throw
away
away your work, and you're like,
Miss Landon.
What?
Thanks to you saying keep the papers, my book bag is full.
No, should I do?
I want paper.
It's funny when you talk with the mask, because it goes,
It fits my face.
but it looks funny as well. And,
What'd you say, Parker?
Jana.
Calculators on the desk, rollers on the desk, do
Someone,
whatever you want with the papers.
someone made a wooden thing out of that mouse before.
There was a key, like, it was a whole keyboard setup too. I did see that.
What if it takes so long? Not all the time and everything.
What?
For the president stuff.
Well, there's just a lot of different stuff happening this year that doesn't really
I've
happen.
seen funny videos of people whenever, like during the pandemic and like this, people are literally setting up in their houses with canned foods and stuff. Just burying a ton of equipment. Besides, if Trump wins, it's fine. Biden,